In this video, we're going to be working on how to solve questions, differentiation questions that have to do with exponential functions. So we're going to jump straight into this, but this is the May-June 2025 paper 21 past paper. Right. Okay. So the question says the diagram shows a curve with the equation y is equal to 6e to the power of 2x minus e to the power of 3x, right? The shaded region is bounded by the axes and the curve, right? So we can just see that from the equation. And then the question says, find the exact, or part A of the question says, find the exact x coordinate of your maximum point. So at this point, you probably know that the moment you see maximum point, you know that this is asking you for, let's just get here. It's asking you for the highest point, which is this point over here, right? We know that that's the point where it levels out, right? Maximum point and minimum point are the point where the graph turns in on itself. So this is the point where, because the moment you see maximum point, you know that we're talking about first derivative. And since this is given in terms of y, let me write this as dy dx is going to be equal to 0, because your first derivative gives you the gradient of the graph. So because the graph is flattening out at that exact point, we know that the gradient is equal to 0. So if you ask for maximum point or minimum point, it means get the gradient, get the point when the gradient or your first derivative is equal to 0. But I want to remind you of one more thing. In this case, they also said find the exact x coordinate, or there's actually 2 points that I want to highlight there. Exact means that we're not going to simplify. We're not going to put it in our calculators. And also, x coordinate, this means we're getting an x point. Right? So these are just the different things that we're just going to get from our question. All right, so let's get into the expression. So our expression is y is equal to 6e to the power of 2x minus e to the power of 3x. So on the right hand side of our question here, I'm just going to be writing different notes just to remind us of the different things that we need to remember to solve questions like this. Right, the first thing that I'm going to write is, when it comes to exponential expressions, right, the derivative, so if your y is equal to e to the power of x, the good thing about exponentials is that with the moment you find the first derivative, it actually doesn't change. The dy dx is e to the power of x. But as we know, Cambridge isn't just going to give you this. Well, most likely, maybe they will, but most likely not. They're not going to give you this expression this easy, right? So what they'll usually do is they'll say y is equal to e to the power of some other expression, f of x, right? So in this case, that's when we put in the chain rule, where instead of having just the x expression, we have a whole nother more complex function. And the chain rule just tells us that what we need to do is we need to say, okay, the first derivative of this expression is, I will take this function, f of x, I'll find the derivative of that function, which is f prime of x, and then I'll multiply it by my the derivative of my original expression, which is e to the power of x, but in this case, it's just going to be e to the power of f of x. So you keep it exactly the same way as it came, right? So we're going to say the derivative of our power multiplied by the original expression. So this is how we're going to be finding the derivative of each of these expressions over here. So let's just jump straight into that. Okay, so like I said, the goal here is to find dy dx and then equate it to 0. So our dy dx is equal to 6 multiplied by, right, because our 6 is just the constant. So actually, maybe I'm just making these, let me space these out a little bit more. That's going to be dy dx is equal to, so what we're going to do is we're going to say, okay, for this expression, our power, or our f of x, our function is 2x. So remember, we said we need to take that function, find the derivative of that function. So what's the derivative of 2x? It's 2. So we're going to multiply our expression by that 2. So that's going to be 2 multiplied by, we still have the 6, that's a constant, that's not going to go anywhere. Multiply that by e to the power of 2x. So that's our first expression. The only thing that we changed here is we multiply by the derivative of our power, just as the chain rule tells us to do. We have to do the same thing to the next expression. You take the power, which is 3x, find the derivative of that power. The derivative of 3x is 3. So I'm going to say 3 multiplied by the original expression, which is e to the power of 3x. Then we're going to simplify this. So dy dx is equal to 2 times 6 gives us 12, e to the power of 2x minus 3. That doesn't really change too much. That's 3 e to the power of 3 of x. Okay, perfect. We found an expression. So now what's the next step? The next step is applying this, right? Remember we said we have to equate this to 0. So 0 is equal to 12 e to the power of 2x minus 3 e to the power of 3x. Okay, now why are we doing this? Where do we go from here? What we do from here is we want to, remember we said we need to find the x coordinate. So this means that we need to solve for x. Okay, so take this expression, you have to make x the subject of the formula. So what I'm going to do is I'm going to take this to the other side, right? Remember when it crosses the equal sign, that negative 3 e to the power of 3 of x, it becomes positive. So this expression is now going to be 3e to the power of 3x, that's positive, is equal to 12e to the power of 2 of x. All right, so we're going to try to simplify this as much as possible. So divide both sides by 3 to cancel out this 3 over here. But this is going to become 3 into 12 is 4. So that's going to be e3x is equal to 4 e to the power of 2 of x. All right. Then we get to this point, right? So this point is a little bit, like where do we go from here, right? When you have logarithms and you're working with logarithms, it's always good to, if they have the same base, to always put them together through multiplication and division. Because we know that from our log laws that if I have x to the power of some value a divided by x to the power of some value b, if this is division, it means that I can join these two, as long as they have the same base, which is x, I can join these and subtract the powers. If it's multiplication, you add the powers, right? So as long as it's multiplication and addition, we can, and the base is the same, we can join the two expressions. But we actually can't do that over here because this is subtraction, right? It's the same base, yes, but the expressions are subtracting. We only do this when it comes to multiplication and division. So just be careful about that. All right, so that means since these have the same base, I can actually divide both sides. Actually, I'm going to divide it by the smaller power, right? I'm going to divide both sides by 2 of x. All right, e to the power of 2 of x. It's going to cancel on this side. But on this other side, what it's going to do is it's going to be, remember, it's division, right? So it's going to be e to the power of this first expression, 3 to the power of x, minus e to the power of 2 of x, right? Let me just explain that a little bit better using this, right? So our expression was e to the power of 3 of x divided by e to the power of 2 of x. Which means since they're the same base, we can combine this to e to the power of the first power, which is 3 of x, minus the second power, which is 2 of x. So this is basically the same rule as that, right? So it's very important just to familiarize yourself with the log laws when it comes to questions like this, right? So that's going to be equal to 4 because remember your e to the power of 2 of x cancelled over here. So 3x minus 2x gives you x. That's equal to 4. Okay. Again, now, our goal here is to make x the subject of the formula. So when it comes to logs, how do you get this x that's a power at the bottom and on its own? So what we do is, right, when it comes to logs, let's just say, for example, you have some expression a to the power of x. If I want to get this to the bottom, what I do is I'm going to apply a log on this. If I apply a log on this, I have to apply a log of the same base, which in this case is going to be a to the power of ax. Two things are going to apply, right? The first thing is if I have log of a power, it's going to get the x to the other side. So this is actually going to come all the way down here. That's going to be x log base of a of a. And then the second thing that's going to happen is that log of a number, log base a number of the same number is going to be equal to 1. So this is going to be x times 1, which actually simplifies to x. Now, how does that apply in our case, right? How it applies is you always look at the base and then you apply the log of that base. So if I have e to the power of a to the e to the power of x, I have to apply log base e to the power of log base e of e to the power of x. Sorry, I'm getting tongue-tied there. Right, now the question is, what's log base of e? Log base of e is what we call ln of e to the power of x. So this exact same thing is going to apply here, where x is going to come all the way down here, right, to make it x ln e, and then ln e is actually going to be equal to 1. So this simplifies to x. So you may have heard at this point that as long as you apply ln to both sides, right, the natural logarithm of e to the x, this is going to be x ln e. Oh, shucks, sorry. You always have to do the same thing to the other side. That is cardinal mistake number 1, right? So if I apply ln to this side, I have to apply ln to the other side as well, right? So this is going to become ln for, I'll just focus on the left-hand side. So I hope that's not too confusing. And then ln e is the same as log e of e. So this is going to be equal to 1, right? So this is ln e. So x times 1 just gives you x. So that means this is equal to ln 4. You don't have to put this into your calculator because remember they said the exact value. The moment they say exact value, it means just don't simplify it beyond this point. Okay, right. So essentially this is how we solve this problem. The most important thing here is just to familiarize yourself with chain rule. It's always good in differentiation to know chain rule. Logarithms, your log laws, those are very key when it comes to these problems. So yeah, I hope this made sense. In the next video, I am actually going to be working on an area shaded, finding the area of the shaded region, which is an integration question in this exact same problem. So I hope I see you in that next video. I hope this made sense. And yeah,